worksheet from earlier. Did I give somebody the copy they had on my right? Guys, just to let you know what you could be doing with this problem. I don't make my regular semester do this either. We could make an entire hypothesis test out of our R score to show that it's evidence of correlation. But, what's happening? Okay. But instead what I do is I just tell you, based on how big the sample is, on a test, on the final I'm going to tell you what R has to be greater than or less than if it's negative, to show evidence of correlation. So it's the bigger R is, the tighter the correlation. But if you have a really small sample, in fact, if you only had a sample of 2, will it ever be different from a perfect correlation? 2 points define a frickin' line, so that R is always frickin' 1. So the smaller your sample, the bigger R has to be to show evidence of correlation. So on the test, I'm going to tell you R's got to be bigger than 0.7 or smaller than negative 3.8 or 0.38. You guys follow what I'm saying? All right, how can I say this better? R can be from negative 1 to 1, right? Okay. R equal to 0 means no linear correlation. Any 2 points, if I just give you 2 points, the line that I draw will go through both of them. So the smaller your sample is, the bigger R has to be to show evidence of correlation. Because if your sample's 2, 3, 4, it's getting to the point where it's almost impossible for it to not be a nice, good, big R. So, for n, like if n was 12, you might need R to be greater than 0.6. But if n was 38, you might just need R to be greater than 0.2. That's the idea. The bigger the sample is, the more certain I am about it, the less evidence I need. It's kind of like related to what we were doing before. So I'm going to tell you, on the test, I will tell you, hey, R's got to be bigger than this for correlation. So what do you say if you get R equal to 0.92? Is that good? Is that evidence of correlation? Is it?
Yeah.
It's greater than freaking 0.6, and that's what I would have just told you. Hey, you need this for correlation, so is this evidence of correlation? Yeah. And then you can go further. What kind of correlation is it? Positive or negative? Positive. And is it strong or weak? Strong. What would weak be? Weak would be 0.62. It beat that, but it barely beat that. So there is correlation. It's weak positive. So what have I got? 0.59. No. No correlation. No evidence of correlation. It didn't get there. So you wouldn't say weak, you'd say none, not enough evidence. So you can imagine how this could become a hypothesis. Have you found enough evidence or not? But I'm not going to go there. I'm just going to be strictly just that one step in a hypothesis test. Here's the thing, can we make it? That's the one step you got to worry about. So here, I'd have to look it up, to be honest. I'm pretty sure that doesn't make it for correlation. But if I didn't give you, the best you could do here is to say it's weak negative. That is weak. Why is that weak? Why is that weak?
Close to 0.
is closer to 0 than it is to -1. So the best thing we can say right now with what we know on this is weak negative correlation, which is what we thought before. And the line of SR, you put that in the calculator, all that kind of stuff. Don't worry about it. Really, I just make you write it down so you can see it, so you can put it in your calculator. So you guys try this one out. Do this problem here. This is related to the, I think this is strong hours versus grades on the front.
What does R have to be to make it?
Just do it,
Okay.
and then we'll talk about it. I got